Hello students, this is Dr. Raipudi. Welcome to our digital platform. Currently working as a postdoctoral fellow at IIT Kanpur. So you are all welcome to the my channel. So if you are visiting first time, please subscribe our channel to get further videos, information regarding further videos. So here I'm going to discuss about scanning electron microscopy, brief description. And in this, I'm going to discuss what is SEM and uh, uh, principle and advantage applications, parts of SEM, and types of detectors, uses, and types of electrons. So, so what is SEM? So SEM is a type of electron microscope which produce different types of images of a sample by scanning the surface with a focused beam of electrons. So here, what is the main significance of these electrons, which provides enlarged images of a specimen's size, shape, and its composition, and crystallography, which means structure. What is the structure? BCC structure, FCC structure, and SCP structures, and other physical and chemical properties of a specimen. So now, if you see the advantages, these advantages are characterized into by considering broad depth of field, which helps to focus on more of a specimen at once. So here, while you are going for some analysis, you need to check depth of field and also high resolution. So what is the resolution of this that particular equipment? So with this resolution, which helps to closely spaced specimens can be magnified at much higher levels. So at a close specimens, we can see clear images at, at higher magnifications. And the applications are, we can see in many industries such as microelectronics manufacturing industries, semiconductor industries, medical devices, and also general manufacturing and food processing industries. So if you see the uses of this scanning electron microscopy, uh, we can see topography. So where we can see surface features of an object, specifically roughness and reflectivity. So by seeing the structure of that specimen, so we can able to tell, one can able to tell what is the roughness of this roughness of that specimen, and also reflection. So if the specimen is a flat surface, which can give high reflectivity. And morphology. So morphology, we can analyze size and shape. Here we can see in below circular sample in the middle, and here we have in the in the left hand side, triangular shape or else irregular shapes. So one can, if you want to measure the size of that particle and shape of that particle, we can also measure. So, and also next, composition. So here, if you want to measure what are the different elements are present in this mm, surface, over the surface of the sample, and we can also measure. So if we have any new sample, if you want to go for analysis directly, you can go for scanning electron microscopy to know the what are the elements present in that sample. And next, crystallography also we can see. Here we can see the atoms are arrangement, so how these atoms are arranged. And the BSc images use contrast, tells us about the average atomic number of elements in the sample. By using this one can able to do quantitative analysis, uh, analysis of the composition. So here the basic principle in this scanning electron microscopy is the high energy electron beam of electrons generated from a suitable source, which is whether it is a uh, tungsten gun or else field emission gun, then field emission gun, which will pass through the certain lenses and certain lenses and detector certain lenses. And these electrons interact with the sample, produces various signals that contain information about the surface features of the sample. And these are the different components we can see. We can see if you go for SEM. So these high energy electron beam will generate in the tungsten gun or else field emission gun, which will pass through the certain components such as condenser lenses, scanning coils, and objective lens, and finally which will interact with the sample. And these electromagnetic lenses which helps us to control the path of the electrons. Mainly these electromagnetic lenses are to control the path of the electron. Condenser lenses which will define the size of the electron beam, so which will condense the electron beam to focus more. And objective lenses which helps to focus of the beam into the sample. And these scanning coils are used to raster the beam onto the sample. So the and also apertures are using along with the condenser lenses or objective lenses to control the size of the beam. And these are the various when high energy electron beam interacts with the sample, which generates certain types of which emits certain types of electrons. Those electrons are called as X-rays, secondary electrons, photons, backscattered electrons, Auger electrons, and some electrons may transfer through the sample. Those may be inelastically scattered electrons and elastically scattered electrons. And out of these, in SEM, scanning electron microscopy, we can observe and to analyze the surface features of the sample. Two electrons are useful. Those electrons are backscattered electrons and secondary electrons. These two electrons are collected with the help of detector, which is called as backscattered electron detector and a secondary electron detector. So this backscattered electron detector is placed just above the sample, which helps to collect the backscattered electrons. And here, the mainly we can see contrast information between different compositions or compounds of the sample. Heavier elements will appear as brighter and lighter elements will appear as lighter, which means lighter means in terms of atomic number, light atomic number, lower atomic numbers. In secondary electrons is placed side of the electron chamber at an angle. So to collect these secondary electrons in order to increase the efficiency of the detecting secondary electrons. So the basic principle, the basic function to keep these secondary electrons inclined with the electron chamber, which is to increase the uh, efficiency of the detecting secondary electrons, which provides more detailed surface information. So here in secondary electrons detector, we can see clearly what is the structure of that surface. So in previous slide, we have seen the structure, which is right hand side, the structure of the specimen. So here we can see paralitic structure. So by using this secondary electron, one can able to see easily the structure of that sample. And so from where we are getting these electrons? So there are certain types of electron sources. Those are thermionic filament, which is in a shape of V shape, white hot temperatures, operates at white hot temperatures, which means it gradually evaporates with time. White hot means which is very high temperatures. So gradually keep on using. So at a certain amount of time, end of time, it will evaporates completely. So eventually breaks, which can contaminate the upper part of the electron. The average lifetime is about 100 hours. So once you start from 0 hours, so which will work still 100 hours. depending upon the vacuum. So here we need to take care about the vacuum, that scanning vacuum of the chamber. So completely closed condition. So the next one is thermionic electron filament, which is also called as a tungsten filament gun. So field emission gun, which is in shape of pin type, generates strong electrical field that pulls electrons away from their atoms. This is more popular and generates high resolution images. However, it requires vacuum design that often comes at high space. So the basic difference between scanning electron microscopy and field emission scanning electron microscopy is the majorly, we can say, high resolutions and also higher magnifications. So whereas if you want to analyze your sample at lower magnifications, one can go for tungsten filament equipped with scanning electron microscopy. And if you want to go for higher magnifications, we can go for a field emission scanning electron microscopy. And also the third type is cerium hexaboride cathode. It is if you compare with the tungsten, which is thermionic filament, it offers 10 times as much brightness. So if we compare with the uh, tungsten filament scanning electron microscopy, which will offer 10 times better brightness, improving both signal to noise ratio and the resolution. The normal service life of this cerium hexaboride cathode filament is 15 plus hours, 1500 plus hours. Whereas in case of the tungsten filament, 100 hours. But whereas in case of CE B6, we can able to use it till 1500 plus hours, which is more than 15 times service life of tungsten. And the basic abbreviation and definitions we can see: scanning electron microscopy is a type of electron microscopy. One, the resolving power of about 2 nanometer and magnification is up to 100,000 x. Here x is very important. They will ask you if you want to go for analysis of the scanning electron microscopy, they will ask you at what magnification do you want to see your sample. So you have to define, or else you have to go to through literature review to uh, know the that magnification levels. So we can say 100 magnification, 100x, 200x, 500x, 1000x. So you can say like that. And FESM, if you want to go for higher magnification, see here almost 3 times than the scanning electron microscopy. So high resolution power and higher magnification in the range of 10 to 300,000x, almost 3 times. And here the main thing is depth of field is very important parameter. So which will gives you the distance above and below the plane of optimum focus within which the image is in focus. And energy spectroscopy. So majorly scanning electron microscopy is equipped with EDS analysis. So by using that one, we can able to quantify the elements present in that sample. So to measure the energy and intensity distribution of X-ray signals generated by the electron beam striking the surface of the specimen. So whether it is if you are considering any element, what weight percentage which presents in that sample. So one, if you want, you can analyze. And working distance, very important parameter, my dears. So working distance is the distance between focus to the normally the distance from the final pole of piece to the lens to the sample when the image is in focus. So This working distance, generally it should be less than 10 millimeter if you want to go for EDS analysis. So if you want to go for any elemental analysis, so the working distance, it should be below 10 millimeter to get accurate results. So WSM tungsten SEM best suited to obtain minimum load resolution with high acceleration potentials. And FESM provides extremely focused and high low energy electron beams, which greatly improves spatial resolution and enables work to be carried out at very low potentials. And this helps to minimize the charging effect on non-conductive specimens and to avoid damage to the electron beam sensitivity. So here, the non-conductive and conductive specimens, if you are having non-conductive elements in your sample, then you need to go for coating. So coating can will be decided depends on your sample. So depends on your sample, you can go for carbon coating or else gold coating. So by using that one, so we can able to analyze the surface of your sample. And lens detectors, these lens detectors are helps to work at high resolutions and very low acceleration potentials. And thank you for watching our videos. If you are having any doubts, so please put comment, and we will try to give you the answer for your question. And please like and subscribe our channel. Thank you.